All right, welcome to the second set of transformations we're going to talk about. Vertical stretching and shrinking, horizontal stretching and shrinking, or the author uses the word compression or compressions for the word shrinking. I think shrinking is easier to spell. All right, so now we are actually going to change the size and shape of our basic function. So I'm still using x squared. So here's my parabola, but we're going to change its shape. And how we're going to do that is we're not going to add or subtract. Now we're going to multiply or divide. So my f of x, x squared, if you multiply any value to a function, in this case 2 times x squared, again, the multiplication of 2 is outside of the x squared. It's after the x being squared. That's going to change your y's. So we're going to take all 5 points again, and now we're going to take every y coordinate and multiply it by 2. So let's start down here at 0, 0. That y coordinate of 0 times 2, that's still a 0. So the origin's not going to move. These 2 points both have a y coordinate of 1. Negative 1, 1, positive 1, 1. Multiplying the 2 to the y coordinates of 1 is going to give me negative 1, 2, and positive 1, 2. So this point has moved up 1 square. Or we're going to say, we didn't shift it, we're going to say the height of this point when x equals 1 has been doubled to 2. These 2 points, negative 2, 4, positive 2, 4, y coordinates are 4. Right now its height is 4 units from the x-axis. Now we're going to multiply the y coordinates by 2. So 4 times 2 is 8. So we're going to double that height up to negative 2, 8 and positive 2, 8. Reconnect our points, and now what we have done is we have vertically stretched our parabola. The x's have not changed. All the y coordinates have changed. That's a vertical. Y-axis goes up and down. Vertical. And we stretched it. All right. Okay, I'm going to leave that graph there so we can compare it to the next example. 1/2 times x squared, or a half times whatever function you're given, whether it's a graph, a set of points, whatever the case might be. Now, multiplying by a half, well, that's the same as dividing by 2. Again, it's before the x squared. We're multiplying before, or I should say not before, after we square our x. It's outside the function. So again, we're going to take all our y coordinates and now multiply them by a half, or if you will, divide by 2. So 0 times a half, still 0. Remember those y's of 1. 1 times a half, or 1 divided by 2, is a half. So now we're vertically shrinking. We're taking the height of 1 and cutting it in half. So negative 1 comma a half, 1 comma a half. These 2 points had 4 for the y coordinates. They had a height of 4. Now we're multiplying it by a half. We're dividing it by 2. So the height is being cut in half. Negative 2, 2, positive 2, 2. This is a vertical shrink or compression. I'm pushing my points down towards the x-axis. That's a shrink or a compression. If I move my points away from the x-axis, that's a stretch. All right. Now, how do I do horizontal stretching and shrinking? I have to be inside the function. So with this example, because my parabola would have been too cluttered, I'm going with the absolute value graph. So that's a V-shape. So my absolute value of x, here's my V-shaped right there. And I'm going to be looking at these points here. So now notice that the 2 is being multiplied to the inside where the x is at. Inside the function. My function is absolute value. 2 is being multiplied to the x before I get to take its absolute value. Now again, remember what we said when we added and subtracted. It would have an opposite effect. So now I got to change my x coordinates because I'm multiplying by 2. But it's an opposite effect. So I'm really not going to take all my x coordinates and multiply them by 2. I'm really going to take all my x coordinates and divide them by 2. So again, starting at the origin, 0, 0, take 0 divided by 2, still 0. But here we have negative 2, 2, and positive 2, 2. Take the x coordinates, divide them by 2. So that's going to make this negative 1, 2. It's going to put it right here. And this positive 2 divided by 2 is going to be a positive 1, 2. So these 2 points are now being compressed towards the y-axis or shrinking towards the y-axis. This is a horizontal compression or a horizontal shrink. Up here we have the point 4, 4, and over here negative 4, 4. Take the x coordinate and divide it by 2. So that horizontal distance of 4 from the y-axis now becomes negative 2, 4. This horizontal distance from the y-axis was a positive 4. Divided by 2 is now 2. So you can see that my graph is changing its shape and size by being horizontally compressed or shrunk to the y-axis. If I want to do a horizontal stretch, then on the inside of my function, we have to have a multiplication of a fraction, or something that looks like we're dividing by 2, because we could call this technically x over 2. So again, opposite effect. We're going to divide by a half. I'm not multiplying by a half, I'm dividing by a half. Well, wait a minute, we really don't divide by fractions. So we could say instead of dividing by a half, how about we multiply by its reciprocal? Multiply it by 2. So 0 is your x coordinate times 2, no change, 0, 0. Okay, now I'm going to look at these points because otherwise I was going to fall off my graph. Negative 2 and positive 2 for the x's. I'm going to multiply those by 2. So this is now going to be, this point is going to go now to negative 4, 2. And this point at 2, 2, 2 times a 2 makes it a 4. I am now horizontally stretching the distance and making it further away from the y-axis. This point at negative 3, 3. Take the negative 3, multiply it by 2, because we're, again, dividing by a half. Better to multiply by its reciprocal. That's going to move me out to negative 6, 3. And same with that positive 3 for this x coordinate. 3 times 2 is 6. I doubled the distance, if you will, from y to the y-axis to the point to now a distance of 3 to a distance of 6. So this is an example of a horizontal stretch. You're pulling your beginning points away from the y-axis without changing your y coordinates. And that's our stretching and shrinking